VCE 2022 Exam 1 question 2b. So it say that evaluate this definite integral from 0 to 1 of fx multiply with 2 times fx minus 3, where the definite integral from 0 to 1 of f of x square, it will be 1 over 5, and the definite integral from 0 to 1 of fx dx, it is 1 over 3. So I have extracted the question here. So in this question, we need to evaluate this definite integral. Now, one more thing we need to understand in method is that when we integrate a product function. Okay, why do I say that it is a product function? Because in this case we have f of x multiply with another function. So in method, when you see a product function, the key to do this question is that we must expand it, because unlike differentiation where you have product rule and also quotient rule, in integration we are restricted, we do not have a lot of rules. So therefore, when you see a product function, the key point right here is that we must expand it in order to solve the integration. Yep. Now, so let us expand this and see what we have. So I have this, and I will label that as A. Now, so let's focus on this product here and let's see what we have when we expand it. So this is a product between the function f of x, right? The function f of x here has been multiplied by this bracket here. So this f of x, I will make it to have green color. And now when you expand it, let's see what we have. We will have f of x, you will time with 2 of f of x, and then you will minus 3 times f of x. I hope it's understandable. Now, so when you have f of x times 2 times f of x, so you will have 2 times f of x square. I hope it is understandable. And then you will minus 3 times f of x. So right now our a here, our integration, our a here, okay, it will become, okay, this integration, when you replace the inside with this expanded form, so you will have this form here. So now up to this stage, what should we do, everyone? So in this stage, one thing that we must use is actually linearity. Okay, what is linearity? It will be this formula here. Okay, so if you have the integration of f of x, I'll make it more general. I'll make it a times f of x, and then you will plus or minus b times g of x, and you want to integrate this. So the key here is that because it is plus and minus and then multiply with a constant, so you can actually expand it like this here. So it will become this, and then you will integrate that, and then you will plus or minus the integration of, now actually you need to bring a outside, and then you will have b multiplied by g of x. Okay, once again, because for integration in method we face a lot of restrictions, so whenever you see a complicated integrand that you need to integrate, please always remember this, because by using this in method, it will make life easier for us. Instead of integrating this whole complicated thing, we can split them into a times this integration, and then b times that integration. So this is the key for linearity. Yep. Now, so let's apply linearity to our integration. So our a here, it will become, let's apply into linearity, so it will become 2, right? 2 times the definite integral from 0 to 1 of f of x square. Don't forget the dx, and then you will minus 3 times the definite integral from 0 to 1 of f of x dx. And do we have this? Okay, this is what we wanted to evaluate, right? So I put under brace. Do we have this, everyone? This integrand there, do we have it? Actually we do. When we look at the question, it is given to us that this is actually 1 over 5, and so this is actually that. Okay, that definite integral, its value is 1 over 5. So let's put everything together, and also this definite integral, it is 1 over 3. Yep. So let's put everything together. So we will have 2 times the fraction of 1 over 5, and then minus 3 times the fraction of 1 over 3. So let's evaluate this. So we will, now this is actually time, and this is also time. So we will have the fraction of 2 over 5 minus the minus 1, and that will give us negative the fraction of 3 over 5. I hope it is understandable. So once again, the key thing for this question is, for method, when you see a product function, and sometimes you will see a quotient function as well, what we need to do in that case is we need to expand that product to break it down. When we expand that product into different terms, then we can apply linearity to that process and thereby get the correct answer. I hope it is understandable. Thank you everyone for watching.